Hello and welcome to my simulation of a non-inverting amplifier. To start this analysis, I've got my operation amplifier connected up as a voltage follower. That's where the output is fed back to the inverting input here. Except in my version I have a resistor R1 which is at 10k. There are two reasons for this. The first is that when we do a simulation, we can see very clearly that the signals at the inverting and non-inverting inputs are equal, even with a resistor in the path here. Regardless of, within reason, regardless of the value of this resistor, the signals at both the inverting and non-inverting inputs will always be equal. That in fact is the action of negative feedback, to force both inputs to be the same. The other reason though is that were any current to flow into the inverting input, a voltage drop would be formed across the op-amp itself, and therefore the signal in could not equal the signal out. In the ideal operational amplifier, no current flows into the inverting input. When I ground R2 and redo the sim, we can see that the signal voltage across R2 remains unchanged. Swapping about the oscilloscope, the output, however, has become much larger. And when we scale it and measure it, you can see it's become 11 times larger. It's become 11 times larger because effectively the output here has a voltage divider formed by R1 and R2. And the voltage across R1 must always be fractionally bigger or smaller than the voltage drop across R2, as in any other voltage divider. Because I've made R1 10 times bigger than R2, the voltage drop across R1 must be 10 times bigger than the voltage drop across R2. Therefore, we have a gain of 10. But of course we don't have a gain of 10 because R2 is equal to the signal input. So the actual voltage gain of this non-inverting amplifier is R1 divided by R2 plus 1. That is all there is to it.